Yo, what's up, subscribers? This lecture is gonna cover AI topic called distributed AI, and let's just get this started so that at any point if we have doubts, we can go further this. So the first thing I like to do is always break down the flow of the chapter so that I know what to expect. So also the group of the tab so that we can make that simultaneously. Okay, so the first thing we go through is what is an agent, how do we build smart agents, and how do you work with multiple agents together and then just applications. The first thing is starting with is what is an agent. Then you work on agent characteristics and the difference between a program and an agent, obviously. Then define intelligent agents, not just uh, basic agents. And you see the architectures. We learned this in the first chapter, logic-based reactive ADI, and then you can layer them. So this was something that I paid attention in class for briefly. There were active and proactive agents, reactive and proactive agents, and when you finally start on the distributed part of it, where multiple agents interact with each other, and this is true. You deploy multiple agents so that you can explore three branches simultaneously instead of going one by one. And okay, we'll see how do you manage them. And okay, so you have to worry about fault tolerance, you have to worry about the communication, um, and ultimately these applications, the product design and planning and scheduling and real-time control and yes. So this is what I'm looking for. Start with what is an agent, characteristics, why do you make it intelligent, internally there's architecture, multiple agents and how do they coordinate again, the typical problems, types, and applications. Okay, so let's start with the slides. Let me just connect my card for a second. Should be visible now. Okay. So now we'll get started to the main crux, and this is where the lesson actually begins. Okay, so you start with what is an agent. It is going to redefine it now. So it is a computer system, in an environment, and it should be capable of autonomous decisions in order to meet design objectives. It's a computer system in a suitable environment where it has the ability to make its own decisions in order to meet a goal and design objectives. Now, how do we say it is actually autonomous? it should be acting without act without human intervention. So apart from human, other systems also can't be interrupted, and it should be make its own decisions, so control over their own internal state and behavior. I think at the end of every few slides we'll have GPT closes so that we are fairly definite about our definitions since we have a different topic. So what is an agent? An agent is a computer system in an environment that can uh, take decisions, that has the autonomous decision making capability to meet its design objectives. What do you mean by autonomy? It should have control over its own internal state and behavior, and it should be able to act without any human intervention or any external aid. That is what an agent is. So, for example, you're traveling agents or systems, multiple robotic systems, search agents, without systems. Uh, yeah, so a user will interact with the buyer agent will interact with multiple agents to get users. So user and these are perhaps human slash other systems. These four here are AI agents. Okay, so the first characteristic that we work on is autonomy. Obviously, the most important one. It is a part of the definition, in fact, and it means that it, if number one can take initiative and control its internal behavior. This is what we said, and there are three ways to do so, or three manners actually, in three manners. Firstly, goal oriented. Secondly, it should be able to interact with multiple agents, a collaborator. And the third part will be flexible. There's also the initiative part, which is self-starting. So back to page 4 graphs. So okay, it can accept high-level requests to complete and decide how and where to complete the requests. It is able to modify the first task with clarification when only is to flexible. Okay, so there will be four characteristics that make an agent an autonomous agent. It should control its own internal state and take initiative, and that can be done in four manners. Number one, goal oriented manner, in which it can accept a job and then decide how to do that. Number two, collaborative manner, can modify that request, ask for clarification, ask the user, and also refuse the request. Number three, it should be flexible. It should be able to reorder the request. It should be able to dynamically choose an action while responding to the environment. And lastly, self-starting. It should detect changes in the environment and choose when to act. So goal-oriented can accept goals, decide how to do them. Collaborative can modify them. It can request clarification, or it can also refuse. Flexible, it can dynamically change the order. or action depending on environmental factors of its choice. And fourthly, the initiative on self-starting, it doesn't choose when to do certain actions, choosing whether to start or not, choose when to start or act depending on environment. Okay, so these are the four you need to determine autonomy. Next is out of sight. Basically, this means that agent does not need supervision, does not need supervision. And another thing is single task. So this is like an RTOS versus GPOS thing. Uh, it should be built for a single task. Yeah, that's literally it. And multiple agents maybe. गोल एक ही होता है, task एक ही होता है. Either there are multiple ones to speed up the process or verify their work or collaborate, but their task is simply one. Okay. The next characteristic that we focus on is communication. For communication, it must collaborate with other agents or users. And repetitive tasks need to be automated. That is the entire point of a robot, I think, otherwise they wouldn't be useful at all. Humans would work themselves. If there's a single well defined task, you should be repeatedly successfully achieve it. It should support conditional reasoning. I mean, now you're thinking of how a human would be, right? There was a chapter over probabilistic reasoning, so that is conditional reasoning, as in dynamic decision making. Dynamic simply refers to something that may change. So as your environment changes, it's dynamic. So your decision also should change according to the environment. Learning. This is important. This is, I think, why we're using AI here and not just DSA. It should be able to learn from its actions, its environment, humans, other agents, and processes. Alright. And reactivity. Now these are the two things I spoke about. Um, perceive environment plus react accordingly. So you first see what is happening and you accordingly react. And then there's proactivity where you predict then change in environment. But uh, okay, so this is more reactive. You should still show goal oriented behavior. Sorry for the fake. Yeah, proactivity means even in um, changing environment, the goal oriented behavior should be maintained. So this is like saying ki, um, you should still want to go as fast as you can, although you'll slow down because of traffic. And okay, temporal continuity, as in the agent should know that time is passing. So continuously running processes. तो एक नहीं देता अपना एजेंट, थोड़ा मेहनती है, ठीक है। हम लेंगे पर्सनालिटी, मोबिलिटी। पर्सनालिटी मतलब बेसिकली ह्यूमन से बात करना आना चाहिए, which टेंडर वॉइस कैनॉट, एंड मोबिलिटी मतलब it can go from one architecture to platforms, etc. You just once again go through all the characteristics that make an agent an agent. Number one, it should be it should have autonomy. The first and most important part is that an agent should possess autonomy, or the autonomy is exhibited in four manners. The first one is that it is a goal oriented, yeah. It should be able to accept high level requests. It should be able to decide how to execute them, or actually decide the order, decide the actions that will help it execute that task. Number two, it should be able to be collaborative in its goal oriented work. In Because it is all autonomous, it should be collaborative in the sense that it can request for clarification, it can modify the requests, deny them altogether. Thirdly, it should be flexible. It should be able to change the order of its actions and tasks depending on the changes in its environment. Fourthly, it should take initiative. It should be self-starting. And by that, I mean it can um, decide when to act depending on the environmental conditions. All of this makes it autonomous, which means it is in control of its own internal state and behavior and capable of taking initiative. Okay. It can act without human intervention or other systems troubling it. That is the first part, autonomy. Because it is autonomous, it is also out of sight. It can work without human intervention. Number three, it should be able to communicate. It should be able to communicate with other processes, other systems, other humans, and other agents. Single task, that is point number three. Um, an agent should be focused on doing one task only. In fact, in an environment with multiple agents, they all collaborate to achieve that singular task. Yeah. It should automate repetitive tasks, as in, given a well-defined task, the agent should complete it over and over again successfully each time. If anything, it should improve because it has number five, learning. It can learn from its environment, humans, other agents, and processes. It should support conditional reasoning. That's point six. I mean, depending on the environment conditions, it should be able to change its actions. Reactivity, an agent should be able to respond to its environment. Proactivity, it should still maintain its goal oriented behavior in changing environments and continue to take initiative that takes it towards the gate. Temporal continuity, the processes inside the agent should be constantly running, there's no rest for our voice. Mobility, it should be able to work on different platforms or architectures and just transport from there to there. And personality, just it can interact with humans, with other agents, and yeah, that is agent's characteristics for you. Okay. So now, sorry, I don't think you can screen. Yeah. We've defined what agent characteristics are, what makes an agent an agent. But then we now want to look into specific type, or specific subcategory, intelligent agents. Not all agents are intelligent. And what makes an agent intelligent is it's flexible plus autonomous behavior. Flexible here means it should be able to reactive, proactive, and socialize. Socialize is sort of same in personality slash collaborator. Okay. Okay, so we just learned what agent characteristics were. We're now diving into intelligent agents. There are two main properties which make an agent intelligent. An agent which is flexible and autonomous is known as an intelligent agent. By flexible here, you mean it has three properties. It is reactive, that means it can dynamically change its actions or the order of actions based on the environment perception. Number two, it is proactive. Even in changing environment conditions, it maintains its goal-oriented behavior and tries to seek to complete the assigned task. Number three, it can socialize. That means it can communicate and collaborate with other agents and units. Okay. Now we dive into how do you build them. That is the architecture. If we just jump back to the GPT slide, you'll see we've done with this. So this is the architecture part. How do we build them internally? Sorry. Um. Yes. So the number one, logic based agents. Number two, reactive agents. Number three, ADI agents. And fourth, layered architecture. Okay. So logic based agents just use logical deduction. We will learn this in some time what logical deduction is, the root predicament and all of that stuff. Reactive agents just have that perception to action mapping that it acts upon. It's like a lookup table and sort of already knows whatever it has to do. A PDA agent is interesting. It works on its belief, desire, and intention. These are stored as data structures. I mean, a simple matrix can show you that, and it should manipulate that to match these. So they work by manipulating the data structures that store its beliefs, that is the perception it has, its desires, that is the goal it has, and intentions, as in the actions it is going to execute to reach that. Layered architecture where you'll just use different levels of abstractions. So decision making is based upon reasoning about the environment and different levels of abstraction. Okay. So architectures here are divided into four primary kinds: logic-based agents, which will just work on logic deduction. For they'll use logic deduction for decision making. The reactive agents, which basically have a perception action mapping, and that is what it will use to make its decision, choose whatever task it does next. Third, you have belief, desire, intentions, where use manipulate data structures to store the agent's beliefs, desires, and intentions, and on that basis make decisions. And lastly, you have layered architectures where you use the environment's perception reasoned by layers at different abstraction levels to make decision. Okay. Beliefs give you desires. Just change this slightly. Beliefs, leading desire, including actions. And this will change of beliefs. This intuitive and clear functional decomposition. Problem is the commitment to intention. ये भाई commitment में ही सब अटक जाता है एग्जाम्पल. किसी का architectural breakdown. So you can have two types of layering. Number one, horizontal, where you have parallel input output. Or vertical, where everything goes through and goes through. Or you can have vertical with feedback. Okay. Well, I don't think there's a feedback possible in horizontal. We check that on GPT. Um, feedback to the horizontal was like that. Okay. So hierarchically oriented systems, as in so this was a point I had asked in class. Hierarchy does not mean one layer is the other's boss. Hierarchy is about the abstraction levels, and that is beautiful because it means how much control each layer has over the robot and not over each other. So yeah, and you should have at least two layers. One of them should be proactive and the other should be reactive. Um, one should still worry about you braking when you're in a traffic jam, but the other should make you go forward instead of having to absolutely stop. Okay, the problem layered architecture is more possible. However, it does not have the clarity that other methods have conceptually and semantically. And yeah, there might be too many interactions between the layers, especially the one with that, and that can cause some problem. So now we done with layer architecture stuff, agent architecture stuff. So I think we'll finish till here the agent types and then go short quiz. In fact, also have GPT explain everything back to us so that we are completely done with this topic. I hope up that everything is clear. Half an hour is not the worst time. Okay. How to search algorithms change when there are multiple agents? Okay, this makes sense. If you have multiple agents, you can divide the task between different agents. You can either divide the tree or you can use different algorithms. So like something like DFS gets to look for the solution while BFS goes and finds you the shallowest solution so that you can find the least shallowest one last. Planning. Okay. So you implement sub goals for each agent instead of so you break down the goals and have each agent worry about their sub goals. and then obviously lookup threads or arc threads. But the problem is there's a lot of communication if you have decentralized communication. And if you have centralized communication, then the second and main central component fails, that our communication breaks down altogether. Now, if we allocate different branches of a TFS tree, then is a solution guaranteed? Solution is still not guaranteed because the whole completeness argument stays. But if it is there, then it will be found earlier. And yeah, if one agent fails in a multi-agent environment, we go for fault targets. We make another agent take over their task, and software agents can be cloned. So just copy it, let the failed one fail, and start another one. So I think we should try to start agent failure. Number one, another agent takes over. Software agents can be cloned. Change the current agent. New agent can learn from. So there's a cooperative versus combative agent thing. This has not been clearly elaborated. We have GPT to just this. इसमें cooperative versus cooperative, self-fulfilling. Should utility of team plus itself be banana should be. So minimum resources. So I think that the GBT explained this to us. There were not enough content over here to understand anything. I think we got this for the lecture here. We'll just quickly run through everything ourselves first mentally, and then hopefully have GPT quizzes and teach us whatever we don't know. Number one, we define what is an agent. An agent is a computer system in an environment where it can um, take autonomous decisions in order to achieve the task assigned. Its design objectives. So that is capable of autonomous decision making in order to achieve its design objectives. Number two, um, we jump from what is an agent to what makes an agent an agent. First property सबसे important autonomy. Autonomy मतलब it is in control of its internal behavior, internal states and behavior, and can take initiative to achieve the goals. Four panels where it can show its autonomy. First one, goal oriented. Yeah, he um, it can accept high level tasks. It can uh, decide the actions to execute them. Next, it should be collaborative. It can request clarification. It can deny tasks completely. It can, yeah. Third is flexible. It should be able to dynamically change its tasks and action plans to suit the environment. Fourth is self-starting. That is, it should take initiative on when to act depending on the environmental conditions. That is autonomy. Next, it should work out of sight. That is more human supervision is required. Third, it should work on a single task. In fact, even in multi-agent environments, multiple agents together try to collaborate to achieve one single task itself. Fourth, now we will list down all the characteristics, right? So, personality mobilities of any method, carrying single task to laptop, proactive reactive capabilities without carrying computer. It should, uh, number one, fourth, it should be able to communicate with other systems, real agents, and everything. Five, it should be able to learn from its uh, environment, from its other agents and everybody. I'm gonna take a look now a little out of here. Out of sight, yes, communication. Automate repetitive tasks. Given a well-defined task, an agent should accomplish it successfully over and over again. If anything, its performance should improve because of the learning element. Conditional reasoning. It should be able to dynamically change its decisions based on the environmental conditions. Learning हो गया. Reactivity, it should react to the changes in environment. Reactivity should not forget its goal-oriented behavior. Mobility, it can move from one system to the other. Personality, it should be able to interact with others. And temporal continuity, some process should always be running inside it. So we forgot automated repetitive tasks and we forgot communication and we forgot learning. थोड़ा हाँ ठीक है. Next, we work on what makes an agent an intelligent agent. It's autonomy and flexibility. Flexibility, going to be defined as it should be reactive, proactive, and socialize with other agents. Now, how do you build an agent? It's internal architecture. They've given us four suggestions. Logic based, that is just logical deduction that we typically use. Number two are reactive agents, which are just based on condition mapping. The decision making is based on condition mapping conception. Lookup table, action. Third, PDI, belief, desires, intentions. Now, इसमें there are data structures which store the agent's beliefs, desires, and intentions, and they are manipulated based on its perception to finally lead to an action. Um, it is good because it is intuitive, and two, um, it can give you very logical functional decomposition. As it would just say tasks that it will make sense to a human mind itself as well. But the problem is that um, it can its commitment to the I, that is the intentions, is typically an issue. I will check why with GPT. I'm not sure. And the fourth type of agents were layered architectures. Layered architectures were most common Neo, but there's lots of missing data on semantics and conceptual way. Also, there can be too much interaction between layers, and that's difficult to handle at times. Two types: horizontal, vertical, with and without feedback. We'll check if horizontal can have feedback. And yeah, there should be at least two layers. One of them should be proactive, the other should be reactive. So that was the type of architectures we're using. After that, we jumped to what happens if an agent fails while our topic. It's other multi-agent thing. So number one, can multi-agents here. If searching algorithms are here, you can divide the task between multiple agents. As in DFS, we can divide sub branches. For you can also use different search algorithms, say in Creeper. Planning where you will assign individual subgoals to each agent and you make sure that you're looking for thread arcs. Also check if you're using centralized communication अगर एक fail हो गया central वाला सब fail हो गया decentralized use because there are lots of messages. we allocate different branches, so if there's a possibility you'll find a solution that exists, but the no completeness is still not present. Um, if there is a solution, you will be faster. There's a possibility you'll be faster. And what if the agent fails? So there are three things. Number one, you shut that agent down and have another agent take over its task. Number two, software agents can be easily cloned. So that follows point number three, where you teach the new agent learn from the current agent. Yeah, agent types. Either the cooperative and self-fulfilling and verified to maximize the utility of the team as well as yourself, business, they know, for example, etc. Okay, एक बार बस इधर चलता है. Yes. What is meant by VDIs, VDI agents, probably for commitment to the intentions. Yeah, these are the three words, I think. Okay. So when we have an assembly line sort of okay. So cooperative agents will share information, they coordinate plans, they will reduce duplicate work. Yeah, swarm the context distributed search. The problem is too much communication. So that's we have combative agents is when they are against each other, strategic types of and one is against each other. It's like a game. And yeah, stop trading that idea. Defend them the same time. Commit. Self-fulfilling prophecies. These are neither fully cooperative nor fully cooperative. They combative. They will try to increase the team's utility, but also the when benefit possible. So it's like the business development using minimum. Okay. Ride sharing drivers. Mhm. Okay. Okay. Right. So pure horizontal design will be here because there's a lot of inter uh, communications they want to avoid. Yes. There's an intention tree concept. The action I am going to commit may get interrupted and I am not sure whether I should stick to the plan. Okay. If it is too committed, it is inflexible with the big matter, the छोड़ेगा ही नहीं eventually. Yeah, if it is too flexible, the वो taxi metro jump करते रहेगा. Yeah, right. Okay, okay. And I think that is the end of the first half. Um, let's just give quick quiz here. I think it's better to give a quiz at the end of this chapter. We've already gone quite over time now. Okay, we now start with distributed design issues. If it is a more ambitious product, you typically don't have a well-defined structure, and you also need more valuable recovery components beside the components. Yes, I don't think I can understand what is happening around my. So I will have GPT teach us this. Slides. 14 is it? 13, 13, 16. Okay. So car वाले diagram वही कि हर चीज वाला concept को so you build independent agents and then you coordinate them. Okay, so it's having teams depicted. If you have an automated configuration design service, configuration design service, so फिर you will first catalog the predefined parts, then you'll see the constraints between components. For example, component A requires component B to be driven, and they will act as is configuration design service. So you know the available components. So you first catalog the predefined parts. Yeah, that is my constraints. And then you build out the reservation that you अपने हिसाब से डिजाइन करेगा and फिर तो आपस में results को कंपेयर करोगे. Next is the follow alter collaborative test beds. They use different software tools, correct, and they cannot communicate directly. So agents act as translators. Palo Alto collaborative test bed. Palo Alto collaborative test bed. So we have different software such as I don't know CAD software and so on. So we talk about the create and coordinate all of them. So they will represent the pre-existing developments and communicate with the components. Mechanical team can collaborate with the mechanical without actually having to transfer the data. Okay, let's just compare these instances. For Java, we go with part structure robot design and on the design, each agent is identified with the object. Pero disappear. So, so control as you can to solve it through the websites and then your power system to set whatever it is. Yes, let's do it. One, yeah, so usually we have the million possibilities. When we start to move it, this is what it is. Concept which is okay, so I'm just gonna summarize these slides real quick. So what that is Palo Alto Collaborative Test Bed does is initially there are four independent geographical teams working on the system of a manipulator in a way. And the idea was to change its for the surface its methodology, its physical weight, that is the solid mechanics and the power system of the sensors. And point is they are constraints imposed on the other end or using different platforms. So it was the agent's responsibility to communicate with each other, start seeing the data from the platform A to platform B, and make sure the systems are compatible. And it's the engineers are only functioning in the individual. So reason the automatic configuration designs are also what is in fact the catalog available options, the second term here. What constraints in the file of time, data forms are this and then not a packet that is responsible agents for product process integrated design. Basically, you have so many options in which you can try to figure out use of a large force. What happens with this stream, you can end up shrinking the possibility, which actually it's a file that is almost as big as me. Um, It's been used to be often begins with so yeah, we started depending on the clothes, we can use the constraints of the person. And then eventually there will be non-religious expression of knowledge and that will help you design the final product. But the properties here on each agent is loaded about one specific whatever. It's a API is yeah. Now let's run the last two slides. And we shall be done with this chapter. I think I will go to this later when I think I've forgotten enough because I want to use this information. So planning and scheduling. Davo system schedules production. So there are three service agents, 700 task agents, and 30 machine agents. 30 machines are available. 700 काम करते हैं and 3 लोगों ने service करने वाला है. So you just negotiate within them. It's a market-driven formation. It's like a free market-driven machines. Okay. Machines in sync that time really available है and the task agents will come pretty soon. Quite the opposite. Contract network is basically bidding where task basically we can change your whole strategy. So total percentage which you have previously practiced. Sentence pretty much what the work expected. This is the Dovey Dave Dave system. Next you jump to real-time function. This represent groups of seem to be only like and sunset. Autonomous decentralized system is used in state lines with the agents represent group of related functions for a single process. Single process equal related functions will be weighted. Autonomous decentralized system. Next is the GM Paint workshop, Julia. Agents represent the intelligent device in the shop and they will look for certain violations and react to them. Third, emerging real time relevant areas that was decentralized system. Next, you have the GF paint shop, which is the zone logic. That brings us to the end of this lecture. With our conscious to love to specific system. Thank you so much. Like and subscribe once.